0 to 1. So higher power will give you the lower value. So integral 0 to pi over 2, integral 0 to pi over 2 sin square x dx is greater than integral 0 to pi over 2. Okay, just a minute, Nasrin. 0 to pi over 2 sin qx dx. Integral 0 to pi over 2 sin square x dx is greater than 0 to pi over 2 sin qx dx. Then come to substitution in definite integral. Madam, if substitution is used, then make sure that the new variable that the function to be substituted the new variable that the function to be substituted should be continuous. The first point should be continuous over the given interval. The second point is otherwise directly you can't substitute. Okay, if the function is discontinuous at a point over the given interval, then directly we can't substitute the function. Second point is there should be 1-1 relation between the new variable and the old variable. The third one, limits should be changed accordingly. Limits should be changed accordingly. So very, very important points. These 3 points are very, very important if you are using substitution in definite integral. If substitution is used, then make sure that the first point is the new variable, that is function to be substituted, should be continuous over the given interval. And the second condition is there should be 1-1 relation between the new variable and the old variable, and the limits should be changed accordingly. Okay. Let us come to an example. Let me explain it through an example. Suppose we have to evaluate integral 0 to pi over 6 e power sin x into cos x dx. Right? Integral 0 to pi over 6 e power sin x cos x dx. Okay? To evaluate this integral, we have to substitute sin x is equal to t. Let sin x is equal to t. If you, here the new variable is t, right? Now check whether the function is continuous or discontinuous over the interval. The function sin x is continuous everywhere in its domain, and you know domain of the sin function is r. Second point is there should be 1-1 relation between 0 and pi over 6, between t and sin x. You see 0 to pi over 6, the function is 1-1, because if you draw any line parallel to x-axis, it will meet the curve at best at one point. So function is continuous. If sin x is equal to t, then cos x dx is equal to dt, and the limits should be changed accordingly. If t is equal to 0, if x is equal to 0, then t will be sin 0 is equal to 0. If x is equal to pi over 6, then t is equal to sin pi over 6, sin 30 degrees half. Thus, we can write integral 0 to pi over 6 e power sin x cos x dx equals integral 0 to half e power t dt. You know, indefinite integral e power x is e power x. This is equal to e power t, limit 0 to half. This is equal to e power half minus e power 0. E power half minus 1. Okay. I hope it is clear to you. Did you understand, guys? Please write in the chat box. Is it clear to you? Okay, let's move forward. So write down a note point. If a function is discontinuous, if a function is discontinuous at a point between the limits of the integral then break the integral into two integrals, then break the integral into two integrals around the discontinuous point. Around the discontinuous okay. So suppose we have to evaluate integral 0 to pi dx upon 4 plus 9 cos square x. Okay. From indefinite integral, you know how to integrate this type of functions. We have to divide both numerator and denominator by cos square x. Then we have to substitute. Then we have to express sec square x is equal to 1 plus tan square x, which appears in the denominator. Then we have to substitute tan x is equal to t, then integrate. Okay. So now divide both numerator and denominator by cos square x. This will be equal to integral 0 to pi secant square x dx upon 4 secant square x plus 9, right? This is equal to integral 0 to pi secant square x dx upon so make it suppose 9. It will be easier for calculation. Upon 4 into 1 plus tan square x 4 into 1 plus tan square x plus of 5. This is equal to integral 0 to pi secant square x dx upon 4 tan square x plus 9. In indefinite integral, to integrate this function, we have to substitute tan x is equal to t. But here, we can't substitute tan x is equal to t directly because, you know, the function tan x is discontinuous at x is equal to pi over 2. Minus pi over 2, pi over 2, 3 pi over 2. The graph of tan x is like this. So at all odd multiple of pi by 2, the function tan x is discontinuous. Tan x is discontinuous at x is equal to pi over 2. So at in the left hand side, in the left hand limit is plus infinity, right hand limit is minus infinity. So since the function is discontinuous at x is equal to pi over 2, we have to break the integral or separate the integral into two integrals. So one of the integral will be 0 to pi over 2 secant square x dx upon 4 tan square x plus 9 plus integral pi over 2 to pi secant square x dx upon 4 tan square x plus 9. Okay. So guys, quickly note it down. I will use the next page. Should I move forward? Hello. Zero to pi over 2 secant square x dx upon 4 tan square x plus 9 plus integral pi over 2 to pi secant square x dx upon 4 tan square x plus 9. This is equal to 1 over 4 integral 0 to pi over 2 secant square x dx upon tan square x plus 3 by 2 whole square plus 1 over 4 integral pi over 2 to pi secant square x dx upon tan square x plus 3 over 2 whole square. Let tan x is equal to t. This implies secant square x dx is equal to dt. Okay, x is equal to 0 implies t is equal to 0. X is equal to 0 implies t is equal to tan 0 is equal to 0. X is equal to pi over 2 implies t is equal to infinity. X is equal to pi implies t is equal to 0. So the first integral will be 1 over 4 integral 0 to infinity dt upon t square plus 3 by 2 whole square plus 1 by 4 integral infinity to 0 dt upon t square plus 3 by 2 whole square. Okay. So integral dx upon x square plus a square is equal to 1 by a tan inverse x by a. 1 by a tan inverse x by a. This is equal to 1 by 4 into 1 by 3 by 2, that is 2 by 3 into tan inverse x by a, that is 2t by 3, limit 0 to infinity plus 1 by 4 into 2 by 3 tan inverse 2t by 3 limit infinity to 0. So this is equal to 1 by 6 into tan inverse infinity is pi by 2 minus tan inverse 0 is 0 plus 1 by 6 into tan inverse 0 is 0 minus pi over 2. Okay. Sorry, I've done a mistake. Just look at the graph of tan x. This is pi over 2. So this is pi by 2 minus. This is pi by 2 minus. This is pi by 2 plus. When x approaches to pi by 2 minus, this is plus infinity. When it approaches to pi by 2 plus, this is minus infinity. Okay. So this is equal to 1 by 6 into pi by 2 minus 0. Tan inverse minus infinity is minus pi by 2. This will be plus pi by 2. This is equal to pi by 12 plus pi by 12. Not 0. Pi by 12 plus pi by 12. This is equal to pi by 6. This is the final answers. Okay. Okay. Is it clear? Write in the chat box. Is it clear? Pankaj. Okay. Next move to then next part is properties of definite integral. Properties of definite integral. Property 1. Definite integral is independent of the variable. Definite integral is independent of the variable. Okay. That is integral a to b f of x dx equals integral a to b f of t dt. Integral a to b f of x dx is integral a to b f of t dt. Then property 2, integral a to b f of x dx is equal to minus integral b to a f of x dx. Already I have explained it through the graph. Again, come to the proof. Let indefinite integral f of x dx is equal to g of x. Then integral a to b f of x dx equals g of x limit a to b This is equal to G of B minus G of A, and integral B to A f of x dx equals G of x limit B to A. This is equal to G of A minus G of B. Okay. This is equal, if you take minus as common, then this one will be G of B minus G of A. This is equal to minus integral A to B f of x dx. Okay, that means if you reverse the direction of integration, then a negative sign will develop. So this is suppose A, this is B, A to B f of x dx. So B to f of x dx, in this direction, it will be positive. If it is B to A, then it will be negative. That means if we interchange the limit of the definite integral, a negative sign will develop. If you want to consume the negative sign, then you have to interchange the limits. Okay. This is your second property. Then come to the third property. Integral A to B f of x dx equals integral A to C f of x dx plus integral C to B f of x dx. Okay. Most of the students think that C must be in the interval A to B, but C can be anywhere. This is suppose A, this is B. C, we can take C in between A and B, we can take C outside of A and B. Okay. First of all, prove it. Let indefinite integral f of x dx is equal to g of x, then integral A to B f of x dx is equal to g of x limit A to B. This is equal to g of B minus g of A. Right? This is the value of the left hand side. Then come to integral A to C f of x dx plus integral C to B f of x dx. This is equal to g of x A to C plus g of x C to B. This is equal to g of C minus g of A plus g of B minus g of C plus g of C minus g of C cancels. This is equal to g of B minus g of A. So which is equal to integral A to B f of x dx. So let me explain the result through graph. जल्दी नोट करो प्ले. This is suppose x is equal to a. This is equal to x is equal to b. Let C be the intermediate point of A and B. X is equal to C. So integral A to C f of x dx. Integral A to C f of x dx is equal to this area red area. Let it be A1. This is A1. And integral C to B, integral C to B f of x dx equals, suppose this blue area, green. This is not blue. Okay, let it be A2. This is equal to A2. Then integral A to B f of x dx, integral A to B f of x dx equals the total area. So should take yellow. This total area means yellow area, that is A3. This total area A3 is equal to A3 equals to A1 plus of A2. This is equal to integral A to C f of x dx plus integral C to B f of x dx. Okay, this is one of the case. Let us take another case. This is x is equal to A. This is x is equal to B. And this is x is equal to C. Okay. Then this is the curve y is equal to f of x. Integral A to C f of x dx equals suppose the green area is this area. This area is integral A to C f of x dx. Let it be A1. Okay. Then integral C to B f of x dx is equal to this area. The integral C to B means in the left hand side direction. So this area will be negative area. Okay. Let it be equal to minus A2. Then integral A to B f of x dx equals this area. Let it equal to A. So A is equal to A1 minus of A2. Okay. So I hope it is clear to you. So guys, your first session is over. Second session I'll start exactly at 9:15. And that session will be very important, very amazing session. Okay. Because I will explain all the properties and solve some important problems on properties.